Day 23 in Algebra 2. And today, let's see, it is Wednesday, November, it's the 13th now, isn't it? Or is it the 12th? It's the 12th. Wednesday, November 12th. Okay, so let's change that. November 12th. Okay, so during the do now time, again, I let people work on the Unit 3 quiz if they haven't started or make corrections. And then we have under here, Unit 4. I gave you something to peek at. We're going to be talking about exponential equations today. So, something that might give you a hint about what an exponential equation is actually what they're called, exponential equations. Exponents. We have solved so many different types of equations now, but we haven't solved one where the exponent is the variable, or we're having to solve for x when it is an exponent. And this is an issue. You usually cannot solve an equation when your x is an exponent. So we have to do something here. First of all, if I'm looking at this first example here, it says 2 to the power of what equals 8. So this is what we're solving for, is x. We have our base number, which is 2. I'm going to put base right here. Our base is 2. Our exponent is what we don't know. So what we have to do to solve for an exponent is we need both sides of our equation to have the same base. 8 is not the same as 2, so these don't have the same base. But what we can do is try to get the bases the same. So what we can do is look at our number on the other side, which is 8. Let's try to think of it in terms of the number 2. So let's try a few things. 2 to the first power. Let's see what that would give us. On our calculators, we're going to learn how to type in exponents that are not 2, because normally we use the x squared button. So if you do not have a calculator yet, go ahead and grab one. We're going to learn how to type in exponent. So let me pause this while everybody gets their calculators. Okay, so we've all got our calculators. Normally, if I wanted to use an exponent, we're used to that x squared button. I would hit 2 and then x squared, and I get 2 to the second power, right? Yes. But how do we get 2 to the first power? Can we do that? Why not? Why not? We can do that. So I'm going to show you. What we can do is type 2 as our base. Clear that. And then instead of using the x squared button, we're actually going to use right above the division symbol, there's an up arrow. Mm-hmm. This puts your calculator into the mode where you can type in a number for your exponent. So we're going to type 1 and hit enter. So 2 to the first power is what? 2. That just means I'm taking 2 one time.
Plus the time, one times 2?
It's kind of like 1 times 2. What it really means with exponents, let's make sure we understand exponents. So over here we have 2 to the first power. That really means I am going to use the number 2 one time. So 2 to the first power is 2. Now 2 to the second power.
2 times 2.
That's the same thing as 2 times 2. That means I'm taking 2 multiplied by itself twice. And we get 4.
So I press 2 and the up button again?
Yep.
And then enter.
2 up button.
That didn't go right.
And then type your exponent in. So I push 2. my up arrow, and now you have to type in an exponent. We're going to use 2 this time. Then hit enter.
4.
Good. You got 4. Okay, so 2, 4. Let's try 2 to the third power. So again, we'll type 2 as our base,
This looks familiar.
up arrow, and this time we'll use 3 in our exponent. So I'll push 3 and hit enter.
3. And that's 8.
And we get 8.
3. Wait a minute. That's not right.
And that matches.
And that does match, doesn't it? Let me make sure everybody can get this. We're typing 2,
2.
up arrow,
Up arrow.
number 3.
8.
Good. So 2 to the third power is 8. But how does that make sense? Because this one we thought of it as 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is not 8.
It's 9.
It's, well, 2 times 3 would be
6.
6.
Yeah.
So exponents are not just multiplication problems. Something different is happening. This is what it means. Your base number is 2. Your exponent tells you how many times do I multiply the base by itself.
Mm.
So how many times do we multiply 2? Basically, that means we're taking 2 times 2 times 2. And now you see we have 3 2's being multiplied, right? Type that in, and you should get 8 also. 2 times 2 times 2 gives us 8. It's the same thing. So when we're using exponents, we're trying to see how many times can I multiply 2 times 2 to get that number. Now, let's take this information back to that original example problem I gave you. So we tried 2 to the first power, we got 2. 2 to the second, we got 4. 2 to the third, we got 8.
So that one's not right.
So which one of these can I replace 8 with? What's the same as 8?
2 times 3.
2, not times 3.
2
to the third.
Yes.
2 to the third power.
2 to the third power. So what we did here is we found a way to make our bases the same on both sides. So let me pull out a fresh paper that actually doesn't have all of this writing on it, so we can do this more cleanly.
So
I'm going to rewrite my problem real
Miss
quick.
Taylor.
Yes.
So those other ones, that other one's not right then, right?
Yes, those other ones are not going to be used in this first example here. So I'm going to rewrite that example. 2 to the what power equals 8. Okay. And again, we said 2 is our base. So what we just tried to do is get our bases to match. Because over here, 8 is not the same as 2. But we just figured out, I'm going to rewrite all of that. 2 to the 1 is 2. 2 to the 2 power is 4. 2 to the third power is 8. Now, when I look over here at 2 to the third power is 8, this has a base of 2. And it's the same thing as 8. So what we're going to do is we're going to replace 8 with 2 to the third power. Okay, so let's make the bases match. Make the bases match. Now I'm going to rewrite my problem. I'm going to write 2 to the x power equals, instead of writing 8, what am I going to write?
2 to the x power
Equals the exponent of 3.
Oh.
Yes,
okay.
we're going to change 8 to 2 to the third power because that's the same thing.
X equals 2 to the third power.
So I have 2 to the power of x is equal to 2 to the power of 3. Have we followed to this point? It's a little tricky. It's a little bit confusing. It's totally different than what we've been doing.
So once you get the answer, you just rewrite the problem like that.
Yep, we're going to rewrite it just like this. So we've made the bases match, and now we've got it rewritten. And you know what we can do once our bases match?
I can go by 2.
I'm going to write here, now that my bases match, so now that bases are the same, they cancel out. We're going to ignore our bases. Now hear me out. This feels weird, but just wait and you'll see what I'm going to tell you. So I'm going to say, now that bases are the same, cross them out. And what would be left over if I get rid of my 2's?
Yeah, exponents.
You just have your exponents. You have your x, your equal sign, and your 3. So now that our bases are gone, all that's left is x equals 3. And you've solved it. X is 3. That would be your answer. Because when I plug in 3 for x, 2 to the x power, well, x is 3, 2 to the third power equals 8. Is that true? Over here, we figured out it is true. 2 to the third power is 8. So it works. It works.
It just confused me because I know 4 times 2 is 8. And I'm like,
Right.
that had me over scratching my head.
Right. So exponents are confusing because they're a little different than just regular multiplying. They're a little different. Let's try that second example, though. Or actually, let's skip down to the third example. Let's go to the one that says 3 to the x power equals 9. So on the first half of my equation, 3 to the x power, what is my base? 3. Okay, so we'll underline that. This is my base. My exponent, I don't know. On the other side of my equation, is my base the same?
No.
It's not. It's 9. So we're going to do the same thing we did over here. We're going to make the bases match. So I'm going to write again. Make bases match. So let's take this base over here, 3, and let's try some numbers for the exponent. Let's see if we can get one that's equal to 9. So we have 3 to the first power. When we type that in, what will we get?
3.
We'll get 3. Let's try another one. 3 to the second power. What do we get?
9.
We get 9. Okay, so 3 to the second power is 9. Now I have a base of 3, and I got my answer of 9, right? So can I replace 9 with 3 to the second power?
Yeah.
I can. Let's do that. So I'm going to circle 3 to the second power. That's equal to 9. So let's replace 9 with 3 to the second power. Rewrite the problem. What should I write when I bring this down?
X
3 to the x power equals,
3 to the second.
yes, 3 to the second power. And we can do that because we just said here, 3 to the second power is the same thing as 9. So I'm replacing 9 with 3 to the second power.
And then with X equal 2, since you have to cross them out.
Yes, yes, because now that the bases are the same, we cross them out. So I'm going to do that again. I'm going to underline my bases. Okay, bases are the same. Bases are the same. Cross them out. And what is left?
X equals 2.
X equals 2.
Shares.
And you've done it. X equals 2. X equals 2. I know, this is uncomfortable because we're not used to it. It's a totally different way of solving.
Ooh.
Let me give you something else. Let's try a bigger number. What about 5 to the x power equals 625?
Oh, boy.
So let's look at our previous problems and see what we did there. First, we looked at our bases. What's the base on the first side of my equation here?
5.
5. My base is 5. What's the base on the other side? Does it match? No. It's not 5, it's 625. It's not matching. So we're going to do the same thing. We want to make the bases match. So again, when we make the bases match, we take the base that we want and start trying different exponents. So I'm going to try 5 as my base. And what exponent could we try? We could go down the line like we did. We could do 1, 2, 3, 4, keep going.
It has to be small numbers.
Yeah. You don't have to start with 1 if you don't want to. Because if I look back at my last two problems real quick, notice how 3 to the first power is 3.
Yeah.
2 to the first power is 2. Any number to the first power is just going to be that original number. So if that's not the number you want, you can skip to the second power if you want it. I'll write it just for keeping things the same. So 5 to the first power is 5. What about 5 to the second power? That would give me 25. What about 5 to the third power?
125.
125. We're getting closer. What about 5 to the fourth power?
625.
Oh my goodness, 625.
Big numbers right there.
Uh-huh. So 5 to the fourth power is 625.
I remember this, but I never paid attention to how it's going.
So if I know that 5 to the fourth power is 625, what can I do?
Replace your 625 with 5 to the 4th power.
Yes. Let's replace 625 with 5 to the fourth power.
You have a problem.
So I'm going to rewrite the problem. You're exactly right. What should I rewrite? Yeah, 5 to the x power equals,
4
5 to the
5 to the 4th
yes,
power.
5 to the 4th power.
You cross them out.
Okay, bases are the same.
Bases are the same, yes.
Cross them out. What's left?
X equals 4.
X equals 4.
Answer.
There we go. There we go.
Wow.
Okay, so let's do one more of these just to really nail it in. And then I'm going to have you guys try a couple on your own.
Okay.
If we can do it. So before I switch the page to try another one, is anybody still writing? I can wait. Okay, let me pause my video. I'll give you guys a second to finish writing. Okay, so I'm going to flip this page if that's okay.
Yep.
And I'm going to give you another example. And this time, as we do this last example here, we're going to write steps out in a little bit more of an organized way and give ourselves a little bit of a guide. So this time, I'm going to give you 6 to the x power equals 7,776.
You lost me 1,000.
We're going to grab a calculator.
Yes, you will want a calculator. You will want a calculator.
The first one I put in, I blown.
Ah, look at you. You'll get good at guessing them after a while.
Yeah.
So, I'm going to let you get your calculator. First, let's label this problem for our notes. Now, you might already have the hang of this. That's awesome. That's awesome. So, remember, again, we first look to see what is our base number. For this problem, what's our base number?
6.
6. So, I'm going to identify my base. My base is 6. So that's step 1. Identify the base number. And another kind of little part of step 1 is once you've identified the base number, see if you have the same base number on the other side. Do we? No, there's no other 6 over here. So I'm going to write in parentheses, do my bases match? If my bases don't match, so I'm going to write for step 2. If they don't match, what we're going to do is take that base number and try exponents to see if we can get a number the same as 7776. So if they don't match, use the base number and try different exponents. So for step 2, what we're doing is we're writing out that 6 as our base, and we'll try different exponents like 6 to the 1st power. We'll try 6 to the 2nd power, and we'll keep going. And again, on your calculator, to type in numbers other than to the second power. We'll type in our base number first. And then what do we use to get into the exponent spot?
The up arrow right above the division sign.
Yes, so you're going to go right above that division sign. There's an up arrow. That's going to get you into the exponent spot. We'll try 1, enter, we get 6. That's not what we want. Now let's try 6 to the second power, and we get 36. That's not what we want. Let's try 6 to the third power. So 6 up arrow 3. And we get 216. That's not what we want. We want to get 7776. So we're going to keep going. 6 up arrow 4. 6 to the fourth power.
1296.
Oh, we're getting closer. 1296. So I'm going to write that. 6 to the fourth power. 1296. 1296. Still not what we want. About 6 to the fifth power.
It is.
There it is. 6 up arrow 6. We get. Oh, I meant to write 6 to the fifth. My bad. 6 up arrow 5. 7776. Look at that.
So the numbers.
Yes. Okay, so once we've gotten our number that we need, we tried different exponents. Now we can replace that number with 6 to the fifth power. We can get the bases to match. So if they don't match, use the base number, try different exponents, and make them match. So we see here, we found an exponent that will make them match. That's step 2. For step 3, let's rewrite our problem. So I'm going to say rewrite the equation but this time only use the matching base numbers. So what will I bring down?
6x equals 6 to the fifth power.
Yes, 6 to the x power equals, or replacing 7776 with 6 to the fifth power because we know those are the same. We just figured that out here. So rewrite the equation with the matching bases. Last step, once I've done that, x equals 5. Our bases cancel out because they are the same. So we bring down x equals, we bring down the 5. And that is our answer. Yep. No. Cancel. We got x equals 5 because we were able to cancel out our same bases. So we've run through a few of these together. I'm going to write a few for you to try on your own or with your table people. what I have to out for you. So let's see. This is 100,000. So there's 5 zeros there. 5 zeros there. Okay. We'll try 4 to the x power equals 1, 6, 3, 4. To 5 to the x power. Okay. So I've written out 4 example problems here. And what I'd like for you to do is I'm going to set a little timer and I want you to try to solve for x on as many of these as you can using the steps that we just learned. So I will pause this and I will set a little timer. Okay, so we've had some time. And let's look at these. So first one, I have 10 to the x power is 100,000. What do we get?
10 to the 5th power.
10 to the 5th power? So what's x?
5.
X equals 5. Did anybody get something different? Everybody got that? Okay, well, we can check our answer. Let's see if when I use 5 for x, I get 100,000. So to check, we're going to type 10 to the x is 5, 5th power. And sure enough, we get it. 100,000. There's a cool trick with tens. 10 to the what power?
The 0.
If I, count the zeros. There's 5 zeros, x is 5. If I wanted to know, I know, it's crazy. So, okay, just a little side example on this. What if I wanted to know 10 to the x power equals...
I was wondering.
The zeros kept going.
So let's see. We always put commas
There's 10.
before
Whoa.
3 numbers. 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay, so what is this? I don't even know what that number is.
Billion?
But we can, that's probably right. Million? So how many zeros are there?
Yeah.
There's 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So x is 10.
Wow.
10s are nice. I like 10s.
Some zeros come in handy.
Yes, they do. 10 zeros.
Put that in your calculator.
Yeah, so let's double check. So 10
No, see, watch what it brings. Oh, that's brought up something weird.
to the 10th power. Enter.
I tried.
Ooh, 1e10. Y'all ever seen that?
No.
So what this is saying is it's trying to put it into think way back. If you guys ever learned about scientific notation.
Oh gosh, I've heard the word.
Yeah, but it's been some years.
Somewhere locked in my brain.
It's been a while. It'd be your calculator's shortening the answer. It doesn't want to put 10 zeros in there for some reason.
You thinking robot.
I know. So this is not a problem that I would probably ask you since you wouldn't be able to check it as easily on your calculator. Obviously, there are no zeros there. Basically, that E is telling you how many zeros there are. So 1 with 10 zeros. I hate that.
So is the E for like the word extra then?
Yes, it could be. There's probably like a meaning behind the E. I'm gonna be honest, I don't know what it means. I really don't know. So I guess we can't check that one, but that was a side thing anyway. So let's go back to our problem. What'd you guys get for 4 to the what power?
4 to the 7th power and equals 7.
Okay, so let's check our answer. 4 to the 7th power. Sure enough, we should get 16384, and we do. 16384, so X
Oh.
is 7. Yes.
Not to interrupt you, but I just used AI.
Oh, yeah?
And it's saying the E stands for exponent.
Oh.
Hey, that's a good way to use AI.
That is a good way.
That's a.
What confuses me, though, is why would they not put 10 E10? Why 1 E10? Because 1 exponent 10 is 1. I don't know. I wonder what that means. It makes sense that the E means exponent, but I don't know why they would put a 1 in the front of the E.
Right. That's what I was like. I was lost. I'm like,
I'm gonna have to
let me see
look
what
that
AI
up
is.
before I can tell you. I don't know myself, honestly. Been a minute. Okay, so we got 7 for the next one. What do we get for this one? 5 to the what power is 25? 2. 5 to the second power, or 5 times 5 is 25. So X is 2. And how about the last one? 3 to the 7. 3 to the 7th power should give us 2187. 3 up 7.
You skip it all if it is the same? Like you skip doing all this if the bases do match?
Once you can get the bases to match, if there is not extra stuff, it's just the number, you can be done. The reason we write the steps out is because sometimes it's not just the number. Yes.
That's what I was wondering too, because I know was gonna have to like work it out how we started out.
We eventually will. But for today, I just want us to get this part understood.
Right.
Yes.
So when we like do this like online worksheet, do we have to do like 5 to the first power, 5 to the... That's what I was doing. I was like, this is kind of time consuming.
It is time consuming. If you're going to write out all your options, that's going to take forever. On a problem like this, you wouldn't have to do all of that. A problem where you would want to write out your steps, maybe. I'll give you an example of one. Let's see. Let's say I'm going to write example harder. Here's a harder example.
Yeah.
Now, what if I had 2 to the x power equals 4 to the x plus 6? That's where it would start to get a little bit more complicated, and we would want to keep track of our steps. You guys want to see? This is not what I'm going to kind of make your exit ticket about. This is more of what we'll talk about tomorrow. But is anybody curious to see what we would do here? Okay. Okay, let's see. So let's follow our normal steps. Let's look at our bases. Step 1, identify the base number. So what's my first base? 2. My first base is 2. And does my base match my other one?
No.
No. This base is 4. So if they don't match, what do we need to do?
Get them to match.
Get them to match. So let's use our base number 2, and let's try to get 4 as 2 to the power of something.
2 to the second power.
Yeah. 2 to the second power equals 4. So let's rewrite our problem, but instead of 4, let's use 2 to the second power. So I'm going to cross out my 4. And now we're on step 3, rewriting the equation with the matching bases. So I'm going to bring down 2 to the x power equals, we're not going to write 4, we're going to write
2 to the second.
2 to the second power. But what still needs to come down?
The +6.
This whole thing actually. There's an x
Oh, the
plus
x.
6. Yeah, we brought down the x here. Now we need to bring down the x plus 6. But here's how it needs to come down. This is in the exponent. We have an exponent already. So we need to bring this down with the exponent. Like this. So it's like we're going to be multiplying 2 times x plus 6 here. Do you see that, what I just did? Bringing this down. Bringing everything down. Now, I've rewritten my equation with my matching basis. I brought everything down. What does it say to do after I've brought everything down, rewrote it?
Get the bases once they match and cancel them out.
Yes, we're still going to cancel our matching bases. So what I'm going to do is cross out my 2's. And now what comes down?
That x equals exponent 2,
Mm-hmm.
then the parentheses, the x plus 6.
X plus 6. Now, when we cancel our bases, we can take the exponents and make them regular numbers. We're bringing down x, we're bringing down equals, we're bringing down 2 times x plus 6. So that's what we just did. And now, what do we have here? We have an equation. Now we gotta solve it.
Put a 1 in there.
So,
And then 2x and then 12 plus 12?
yes. So here's where we can distribute 2 times x and 2 times 6. 2 times x is 2x. Plus 2 times 6 is, you said, 12.
Oh,
Yeah.
we could divide.
Bring down equals, bring down x.
Perfect.
So let's get everybody to this point, and then we're going to talk about our options.
Because you can't really
Because we can do something here.
do that.
We have an equation with variables on both sides. There's an x here.
You did 2x. And then put the 12 on the
Okay.
other side.
Yes. So let me rewrite this again where I have a little more room. X equals 2x plus 12. And let's combine like terms. We're going to get our x's on the same side. So, Emily, you said let's subtract 2x. Let's do that. Okay. My 2x's cancel. Now, what is this 1x here minus 2x?
It would be negative 2x. Or negative something x.
Negative what?
Negative 1.
Negative 1. Negative 1, because this is like having 1x.
And if you take away 2,
Yes.
that's 4.
You'll be left with negative 1x
Okay.
equals what? 12. And now we can divide by negative 1. And we get x equals,
Negative 12. This is a giant puzzle.
I know, it's like a big puzzle. Okay.
That's not that bad.
It's not horrible, but it's a lot of steps. And it feels uncomfortable because it's like brand new. It's brand new. So that's what we can look at tomorrow. We're going to do lots of practice with that tomorrow. Today, we're not doing all that. This is just a sneak. So, we have done a bunch of problems where we didn't have to do all that, but this is looking ahead. Tomorrow, we'll talk a little more about how they can get more complicated. For today, it is 10:15. I told you we'd have a shorter class today. We will have our final exit ticket for the week right now. I'm going to give you a single exponential equation to solve. Once you solve it, you're free to go.
For the rest of the period?
For the rest of the period. We're halfway through, and anybody that still needs to finish Unit 3, please stay. Please work on that. Everybody else, I'm going to give you an exit ticket. I will make copies of it, but it's a small problem, so feel free to write it yourself if you don't want to wait. But this is, I'm going to write algebra 2. This is the day 23 exit ticket. So please write on your paper, if you're doing it yourself, write that it is the day 23 exit ticket. It makes it a little easier for me to keep track of it and title it. This is due on Friday. But I'm sure most of you will finish it right now. So you're going to solve for x. And the problem I'm giving you is, let's see. Four to the x power equals 262, 1, 4, 4. So 262,144. Solve for x. That is your problem. You finish that, you're free to go. I'm going to write the due date, and then I will make some copies of this.
I've been having such a conundrum with some now that this one is over. Because to be honest with you,